Hello YouTube and welcome back. Some times ago I received a few questions about my drilling machine, which I occasionally use as a mill also, because I don't have one yet anyway. And this bench drill machine is just an ordinary drill machine, which I of course modified in several ways. The first one was to add a Z-axis digital indicator, and that was it was quite easily added, and it works quite well. Well, not quite well. It works very well. It's been added to this, and I use it frequently. And the most important modification is to modify the chuck. I mean, the chuck is just an ordinary drill chuck, and that can of course not be used for milling because it doesn't have a drawbar, and it will drop out when you mill with it, because it simply is not enough. But it is an MT2, so MT2 ER chucks are commonly available, and I decided to buy an ER25 type, which I considered as large enough for me, so I went for that. But the problem is that the drill machine arbor doesn't have a through hole, so you can't really attach a drawbar, which this of course needs. It's an M10 drawbar. So how to solve that? Well, it wasn't as difficult as you might think, and I will show you how I did it. So the idea I came up with is to make a flat bar which can be inserted in this hole, and then drill and tap the flat bar so that I can screw in a screw from below through the hole in the arbor. But of course that cannot be done with a 10mm, because this hole through is only 7mm, so that would be impossible. And also some goods are needed for drilling and tapping. So what I did was I took this flat iron bar and cut, of course, to almost to the right length, and then I actually ground down using my grinder to the right size, so that it will be 7mm, because of that hole in the arbor. And it's almost 7mm, but it was good enough. I thought that if I drill and tap a 5mm M5 hole in it, then it should be good enough for, well, most light applications anyway. And that's what I did. I drilled, cut to the shape, the exact size, so that the arbor can rotate in the drilling machine, and then of course ground down the surfaces, drilled a hole and tapped it. I thought that if I just use the hole, then it will not be a very good solution, because it's really, I thought it will not be a very good solution. So I had to do something about this large M10 hole and fill it. And the way I did that, it was I took a M10 screw, cut off the head, and then to the right length, and I simply drilled a 5mm hole in it. And this can be screwed in into the shank, and now I can insert a screw, and it is really holding very stable. So what happens is that I just take an Allen key and insert it when it's in the drilling machine, and then I just simply screw this screw in until it is tight enough to hold the AR-25 collet, and that's it. It's really, in the end, it's very simple. It is holding really good. I even used it for milling in steel, but of course one problem is that it's a drill machine, so it is not made actually for milling, but if you are careful, you can do it. So what I do is I insert first the AR-25 shank, like if it was an ordinary drill chuck, and then insert this flat bar in this hole, and take the Allen key and just play with it until it reaches the threaded hole, and then just simply screw it in until it is tight enough. And there is no way this chuck will fall out like if it was just an ordinary drill chuck. And as you can see, it is rotating freely. And it's not very easy to see, but I mean, you can see that it is rotating inside without touching the quill. And of course, if I just start it, and of course if I start it, it will also work smoothly as it's supposed to be. But if you make this modification, you have to be very careful to make the flat bar as so that it is not touching the quill, because if it does, then of course it will damage your machine and it will not work. But that's it. It's really a very simple modification which almost anybody can do, and it is many times better than just using an ordinary drill chuck, like some people do, and I would advise strongly against that. Of course, to be able to mill anything, you need a compound table also. So I bought this one through Amazon, knowing that it doesn't have enough precision, but it's good enough for my experiments. And I also knew that I can add a digital readout, which I also did. What I did was I bought some digital caliper of the right length and simply made an interface using Arduino Uno and some programming. What it does is simply reading the digital caliper value and display it on this display. Of course, I can zero any of the axes here, or also using the original button here. Currently, I didn't attach it to my drill machine because I just moved to a new location, and I still haven't had any need for the mill, so it will have to wait. I have other priorities. So that's it for now. Now you have seen how I am using my drill machine as a mill. But please note that this is a drilling machine, it's not a mill. Regardless what you are doing or whichever modifications you make, this is still a drill machine, and it doesn't give you the accuracy you might want from a real metal mill. But it's okay for simple works, and well, that's it. It's the machine is a drill machine, no question about that, but it works reasonably well for my needs for the moment. So thank you very much for watching, and thank you and goodbye.